Hello students! In our last video, we have seen some important applications of the fundamental theorem of arithmetic and also learned about some important properties of real numbers. In this video, let us revise our knowledge about rational and irrational numbers. Students, recall real numbers include both rational numbers and irrational numbers. So the question arises, what rational and irrational numbers are? Students, rational numbers are the numbers that can be expressed as a fraction or ratio of two integers. That is, they can be represented in p by q form. Whereas irrational numbers cannot be expressed in p by q form. Do you know, students? Both rational and irrational numbers can be converted into their decimal forms. And from their decimal forms, we can distinguish between rational and irrational numbers. Their decimal form also helps us in visualizing the representation of these numbers on number line. So first, let us understand the decimal expansion of rational numbers. For that, let's perform basic division of different numbers. Say 7 divided by 8, 10 divided by 3, and 1 divided by 7. The basic division of these numbers by long division method is on your screen. As you can observe, in case 1, that is when we divide 7 by 8, the remainder becomes 0. In such cases, quotient will terminate. That means it will end up with fixed digits after the decimal point. When we divide 10 by 3, we observe that the answer of division is 3.333, which is its quotient. That is, the division for this number will never end. Such kind of decimal expansion is called non-terminating decimal expansion. Also, observe that 3 is repeating. That is, it is reoccurring. Therefore, it is called as recurring decimal expansion. When we divide 1 by 7, the answer is, that is, quotient is 0.142857, 142,857 and so on, which is again a non-terminating. But observe, students, it starts repeating after a fixed number of digits. This fixed number of digits is called the period of decimal expansion. Therefore, from these examples, we can conclude that the decimal expansion of rational numbers is either terminating or non-terminating, but reoccurring or recurring. Its converse is also true. That is, if we see the decimal expansion of any number is terminating or non-terminating but repeating, that is reoccurring, then the number is a rational number. Students, now let us know what is the period of decimal. For that, let us take division of 1 by 7 and its decimal expansion. We see that decimal expansion is 0.142857, 142,857 and so on. Here, the group of digits 142,857 gets repeated. And as you can observe, this group contains 6 digits. So the period of decimal is 6. So students, when we do the long division of a rational number, the quotient has a group of digits after the decimal point, which gets repeated. The number of such digits in such a group is called the period of decimal. Students, it is not necessary that every time the period of decimal is same. In fact, for every decimal expansion, period of decimal is different. For some, it may be 2, for some, it may be 3, 16, 21, etc. Now look on your screen. The given table shows the decimal expansions of different numbers. And as you can clearly observe that period of decimal in each case is different. It can be 1, 2, 3, 6, 16. For some it may be 18, 21, 22, 28 and so on. In some cases, the period of decimal can also be 0, which means that there are no group of digits which are getting repeated. So students, we have seen the decimal expansion of rational numbers. But as we know that irrational numbers are those which cannot be represented just like rational numbers in their p by q form. So their decimal expansion will also be not the same as rationals. Say for example, the decimal expansion of an irrational number 2 is 1.414235 and so on, while that of root 3 is 1.7320508075 and so on. Similarly, decimal expansion of root 5 is 2.23606797774 and so on. In all the examples, we can observe that decimal expansion of irrational numbers is non-terminating and non-repeating. That means the expansion never ends and the digits never repeat. So now that we have seen the decimal expansion of rational and irrational numbers and the characteristic feature, let us take an exercise to check whether we have understood or not. For that, let us take few examples of decimal expansion and decide whether a particular number will be irrational or rational. Our first decimal expansion is 3.333. Here we can see that the decimal expansion is non-terminating, but it is repeating. The digit 3 is getting repeated after the decimal point. Therefore, this decimal expansion is non-terminating and repeating, and hence the number will be a rational number. In our second example, 0.875, the number will be rational number because the expansion is terminating. That is, it comes to an end after 5. In third example, we can see the decimal expansion is non-terminating. That is, it will never end. But the group of digits are repeating after a certain digit band. That is, 142857 is getting repeated. Therefore, the number will be rational number because its decimal expansion is non-terminating but repeating. In our fourth example, the decimal expansion is non-terminating and also you can see it is not repeating. Therefore, the number will be irrational number. In our last example, you can see that decimal expansion is non-terminating and non-repeating. Therefore, the number will be irrational number. So students, we learned how to convert rational and irrational number into their decimal forms. That is simply by long division method. But students, we also learned that if only decimal expansions, that is, the decimal forms of numbers are given, then from that also we can identify whether the number is rational or irrational. Students, in the next video, we will learn how to prove numbers like root 2, root 3, root 5 as irrational.